Okay, so we have completed the sampling part. Now we need to focus in on Fourier analysis. Okay, so that is our topic. That is what we are going to start today. Okay, so that is Fourier analysis. Okay, that is Fourier analysis. This is Fourier analysis. Okay. Now I think so you have learned this Fourier analysis related with continuous time signal. Continuous time signal. Actually, there you have learned two approaches. What are they? Can anyone remember? Can anyone remember this? So you have learned Fourier series representation. Fourier series representation. And what is other one? That is Fourier transform. These two techniques you have learned. Okay. So actually, these are some signal analyzing techniques, signal analyzing tools. Okay, very powerful signal analyzing tool. This Fourier analysis is this very powerful signal analyzing tool, mathematical tool. Okay, so there are two techniques: Fourier series representation and Fourier transform. Fourier representation we use for what? Can anyone remember? Fourier series represent එක අපි පාවිච්චි කරේ මොන වගේ signal analyze කරන්න? මොන signal represent කරන්න? Period. Yes, very good. That is period. To analyze periodic signal, we use Fourier series representation. To analyze non-periodic signal, we use Fourier transform. Okay. So that is with continuous time signal. Continuous time signals. Okay. So related with the continuous time signal, you have learned this both representative. Okay. So actually here we have two representation. Fourier series representation. One thing is complex exponential Fourier series and trigonometric Fourier series. Okay. So that those are the two techniques we have learned under Fourier series representation, and Fourier transform also we have learned for non-periodic signals. So, so I also explain you the basic concept behind this Fourier series analysis. That is, we have learned 5 basic signals: unit impulse signal, unit step signal, complex exponential signal, complex exponential signal, J alpha t, sinusoidal signal. These 5 signals we have learned on the basic signals. Okay. And there are some corresponding signals, discrete time signals. Okay. That is delta n, n, e to the power plus or minus j n, e to the power plus or minus. Actually, this is a sinusoidal signal. This is a repetitive signal. So if I write this omega naught, okay. So here we have omega naught divided by omega s. That is the sampling frequency t. Here j. Cos also you have learned that cos omega naught n. So it should be divided by omega s. plus 5. So these are the basic signal, continuous time and discrete time signal we use. Okay. So actually, if you sample this signal, we can get this discrete time signal. So when you are sampling this periodic signal, these two are periodic signals. These two are periodic signal with fundamental period. These are periodic signal. Fundamental period is 2 pi divided by omega naught. This is the fundamental period. This omega naught is the fundamental frequency, angular frequency. We have learned these things, okay? This omega naught is angular frequency. This is angular frequency. So this T naught is the fundamental period, okay? So you have learned these 5 basic signals, okay? And so using these 5 basic signals, you can represent other signals, okay? For example, we have seen how to represent a signal using delta T and UT in our interaction class, okay? So we try to understand that one, okay? In the same manner, you can represent any periodic signal as a collection of these exponential terms and sinusoidal terms, okay? So actually that is referred as the Fourier series representation, okay? And Fourier transforms as well as Fourier transform, okay? So using the Fourier, so I also told you that for this periodic signal, these two are periodic signal, there is a fundamental period, okay? That fundamental period, this omega naught is the frequency component, omega naught to F naught, okay? This omega naught also related with the frequency F naught. That is, you know that omega naught is equal to 2 pi F naught, okay? So there is a fundamental frequency. This omega naught is a fundamental frequency, and that is the frequency component this signal has. Okay, that is the frequency component. So sinusoidal or this complex exponential signal has only one frequency component. Only one frequency component. These are very important, and you need to remember these things. One frequency component. Okay. You need to remember this. Okay, now you should remember this. The sinusoidal and complex exponential signal are periodic signals. So it is repeating so that it has a frequency. That frequency, only one frequency is there. So only one frequency component is there. The frequency component is also referred as harmony. So sinusoidal signal or complex exponential signal has one harmony. Okay, you need to remember that. This part is very important. You need to remember this. Okay. I have repeated this several times, okay? So now you should familiar with this concept, okay? Okay, so for example, if we consider any signal, let's say that, let's take the uh, example in this book, okay? So let's take one continuous time example because you are already familiar with the continuous time, okay? So I will take continuous time example. Fourier analysis of continuous time signal, okay? So actually you no need to refer this chapter. May chapter එක refer කරන්න අවශ්‍ය නැහැ කට්ටියට. Because we are going to analyze discrete time signal. Fourier analysis of discrete time signal. Actually that is the chapter 6, okay? So actually we are going to learn chapter 6, okay? And we are going to learn the concept in this chapter 6, not in chapter 5, okay? But I just use one or two example here to remind you the concept, okay? To remind you the concept and try to give you idea. If you couldn't perfectly understand, maybe at that time, maybe you didn't perfectly understand this, okay? So try to understand this at this time, okay? Okay, so this is the Fourier analysis. Okay, and the introduction is there. Okay, so you can read this introduction. Okay, okay. Uh, so you can see that Fourier series and Fourier transform, which convert time domain signal into frequency domain or spectral representation. Okay, so that is the function of the Fourier series representation. It convert time domain into frequency domain. Okay, it convert time domain into frequency domain. Time domain into frequency. Okay, so time domain we normally referred as waveform. Waveform. If we have a voltage signal changing with respect to time. So this is a time domain signal because that signal is changing with the time. This is a time domain signal. Okay. And we called it waveform. And what is the instrument we use to measure time domain signal? Please tell me. What is the instrument we can use to check or observe time domain signal? Instrument. What is the instrument to observe time domain signal? What is the instrument? You have used this several times. What is that? Tell me someone. Already can time domain signal එක මනින්න මොකක්ද instrument එක? What is the instrument? I need the answer. Waveform එකක් බලන්නේ මොකක් පාවිච්චි කරලා? Oh, yes, that is the oscilloscope. That is the oscilloscope. What are the oscilloscope we have in our lab? What type of oscilloscope we have? මොනවද අපිට තියෙන oscilloscope?
Digital.
Yes, digital storage oscilloscope. What are the other type? This is a digital oscilloscope, digital storage oscilloscope. What is the other type?
Analog.
Yeah, what is the name for that one? That is analog one. What is that? Cathode ray oscilloscope. This is the analog, and this is the digital. Okay. So time domain signal, this kind of time domain signal is we referred as waveform, and oscilloscope can be used to observe a time domain signal. Okay. Now using Fourier analysis, you can convert this time domain into frequency domain. Okay, that means here you are plotting the voltage level with respect to time. Voltage level with respect to time. Okay, in frequency domain, what you are going to do? If we convert this signal into frequency domain, that means what we are going to do? So we are plotting the voltage. Actually, most probably we are plotting power, not the voltage. Okay, we are plotting power or voltage. You can use anything, power or voltage of the signal with the frequency. Okay, most probably we are plotting power actually, because if you consider sinusoidal signal, the voltage is changing, no? But power is not changing. Okay, so with respect to frequency, you can plot the power. Okay, you can plot the power. So that is frequency domain signal. That is frequency domain signal. Frequency with respect to power. Okay. So what is the instrument we can use to see this is so this frequency domain signal, this is also a signal, we call that as a spectrum. This is called as a spectrum. Okay. This is called as a spectrum, frequency domain signal. Okay. Okay. The time domain signal we normally referred as waveform. The frequency domain signal we referred as a spectrum. Okay. So what is the instrument we use to see spectrum? Maybe you haven't used that term, but in our laboratory we have that instrument. What is that? What is that? That is spectrum analysis. That is spectrum analysis. Okay. So time domain signal. Okay. Time domain signal. Maybe like this. Okay. Like this. Okay. Okay. So maybe voltage is changing in the time. Is represent. Okay. So this is a time domain signal. We called it waveform. And this waveform can be observed through oscilloscope. So using Fourier analysis, if you convert this, okay, now we are plotting the power or voltage with respect to frequency. Okay, so that is frequency domain signal. That is frequency domain signal. We normally called it that spectrum. We are using spectrum analysis. Spectrum analysis to analyze this spectrum. Okay, now I ask you a very simple question. Okay. If I am sending, if I can use signal generator and I can generate a sinusoidal signal with 20 peak to peak, 20 peak, cos 500 peak. Okay, okay. And this kind of so I using a signal generator, I get this kind of sinusoidal signal. Okay, okay. Then I give this signal. Okay, so this is a signal generator, and there is a coaxial connector. Okay, and I get that signal out. Okay, and I'm going to give it to the oscilloscope. I give it to oscilloscope. Cathode ray oscilloscope. Okay, this is oscilloscope, and this is the signal generator. This is a signal I generate. Okay, so what type of signal I can see here? What is the signal we can see? Can you draw it? Please draw the signal we see on this cathode ray oscilloscope. Let's say that you are sending this signal at t is equal to 0. So what type of signal you can see? What type of signal you can see? So time is going. Time is going. Okay. So you know that we can see a sinusoidal signal like this one. This kind of signal we can see through oscilloscope. This is the signal we can see. Actually, this is the waveform. This is the waveform we can see. So here, 20, and this will be minus 20. And what is this time? What is this time? What is this time? Please tell me what is this time. Quickly tell me what is this time. The time here. The frequency is 100. So what is this time? Now you should be able to quickly tell those things. What is the time? Please send me through chat. What is the time? What is this time value? If you show this through oscilloscope, what is this time value? This is the frequency. අග්ගල කියන්න ළමයි. ඔකට දැන් මේක පුළුවන් වෙන්න ඕන. මොකක්ද එතන time එක? මේ time එක කියන්නේ calculate කරන්න. frequency එක 100. මේ point එක කියන්නේ cycle කොච්චරද? If it is a frequency, you can calculate the one cycle time. The frequency is given. This is the number of cycle per second. Then you can calculate one cycle time. So 100 time per second, 100 cycle per 1 second. Then what is the time for one cycle? තමයි මේක උනන්දුවෙන් අහගන්න ඕනේ. මේ උනන්දුවෙන් දැනගන්න ඕනේ කට්ටිය. දැන් මේ වගේ එකක් පැටලෙන්න විදිහක් නැහැ ඔය කට්ටියට. මම සෑහෙන පාරක් කරා. මේ frequency. This is the frequency. Number of cycles per second. This is the frequency. Number of cycles per second. Okay. So that means 100 cycle per 1 second. So what is one cycle time? That is 1 divided by 100. This is one cycle time. So that is equal to 0.01 second. This is one cycle. Okay, is this time 0.01? Is it correct or not? If I put here 0.01, is it correct or not? No. මේක හරිද වැරදිද? Yes, wrong. Thank you. Okay. That is wrong. So actually, what is the wrong here? And then what is the actual value? This is not a cycle, no? This is not a cycle. Actually, here, this is the cycle. This is the one cycle, okay? So the time, one cycle time should become here, 0.01 second here. And what is this time? It is tell me, what is that cycle time? It is. So it will be actually, this is the half of a cycle. So half of this value. So it will be 0.005. Okay. So this kind of signal you can see through the oscilloscope. Okay. Okay. Now what you do, okay, you are going to disconnect this. Okay. Now you connect this one to a spectrum analyzer. This is to a spectrum analyzer. Spectrum analyzer. So what kind of signal you can see here? Can you imagine what kind of signal you can see here? What kind of signal you can see? Now you connect this signal generator value, this signal, to a spectrum analyzer. Now what is it plotted? It plot frequency with respect to power or voltage. Actually, it it uh, it most probably plotting power. Okay, power value of this signal. Okay, what is the power of this signal? What is the power of this signal? How we can measure the power of this signal? So I think you have learned it in signal and system. Okay, signal and system. Okay, so there are many type of signals. Okay, there are many type of signals. Okay, these are some type. Okay, continuous time, discrete time, analog, digital, real signal, complex signal. Okay, real signal, complex signals. Okay, deterministic signal, random signal, even odd signal. These are some types. Okay, periodic, non-periodic. Okay, at least you should be familiar with this. Continuous time, discrete time, analog, digital, continuous time, discrete time. You need to know what is discrete time signal, continuous time signal, analog signal, digital signal, periodic signal, non-periodic signal. At least you should know these type of signals. Okay. මෙන්න මේ සිග්නල් තුන සාමාන්‍යයෙන් නිතරම පාවිච්චි කරනවා. මේ සිග්නල් තුන මොනවද කියන එක දැනගන්න. Continuous time, discrete time we have discussed so many times. Analog, digital also you know. And periodic and non-periodic also we have discussed. Okay. So you should know what are these signals and what are the properties of these signals. Okay. So that is very important. So if you have any problem, you can come and ask me. Okay. I am at the optical lab in weekdays. Every day I will be here from 9 to at least 4. Not 4 actually. Normally I am staying here around 8 o'clock. Okay. 7, 8. Maybe in some days I will not be available, but most probably I am available here. Okay. So if you couldn't understand these things, you should come and ask me. Hari. ඔකට්ටියට ඒවා තේරෙන්නේ නැත්නම් මොකද්ද discrete time කියන්නේ, continuous time කියන්නේ මොකද්ද, analog එකක් කියන්නේ මොකද්ද, digital එකක් කියන්නේ මොකද්ද, non periodic signal එකක් කියන්නේ මොකද්ද, non periodic signal එකක් කියන්නේ මොකද්ද? ඒවා තේරෙන්නේ නැත්නම් ඒවා ඇවිල්ලා අහන්න. කවුරු හරි ඔකට්ටියකින් analog signal එකක් කියන්නේ මොකද්ද, digital signal එකක් කියන්නේ මොකද්ද කියලා අහලා ඔකට්ටියට උත්තර දෙන්න බැරි වුණොත් එහෙම ඒකේ වැරද්ද මගේ පැත්තටත් එනවා. හරි? ඔය මම තමයි ඔකට්ටියට signals ගැන උගන්වන්නේ. හරි? සිග්නල්ස් ගැන උගන්වන්නේ මමනේ. එතකොට ඇනලොග් ඩිජිටල් ඔකට්ටියෙන් අහලා කවුරු හරි බෑග් එකපු ගමන් ඔකට්ටියෙන් අහන්නේ කවුද ඔය ඉගෙනුවේ කියලානේ නේ. අයියෝ ඉගෙනුවේ නැද්ද කියලානේ අහන්නේ. එතකොට ඒකේ වැරද්දෙන් කැලලක් මටත් එනවා. හරි. ඒක නිසා ඔකට්ටිය මේවා ඉගෙන ගන්න. If you can't, if you need any help, you can come and meet me. හරි. So we are here to help you, okay? To improve your knowledge. Actually, that is our responsibility, okay? So you can come and ask anytime your problems. No problem. Okay. So and other things, energy and power signals. I think I hope you learned this one also, but maybe you can't remember. That's okay. No problem. Okay. So there are two types of signal, energy signals and power signal. This is the definitions. Okay. So the power energy of a signal can be calculated using this one. Okay. You get the signal and you need to get the get the absolute value and square it, you need to integrate. Then you can calculate the energy of the signal. Okay. And power of the signal you can calculate in this way. This is the energy and this is the power, normalized power. You can calculate using this. You need to integrate it and you need to evaluate the limit also. Maybe these mathematical things may be not familiar with you. Okay. But you know how to integrate. Okay. Integration you know. ඉන්ටග්‍රේට් කරන්නට ඔකට දන්නවා සාමාන්‍යයෙන්. හරි? සාමාන්‍යයෙන් මොකක් හරි එකක් දුන්නාම ඉන්ටග්‍රේට් කරගන්න, ඩිෆරන්ෂিয়েට් කරගන්න ඔකටට පුළුවන් වෙනවා. හරි? යම් කිසි ලෙවල් එකකට. හරි? So using this integration you can calculate the energy and power. Okay? And if you consider periodic signal, okay? Okay. So this note is the periodic signal is a power signal. Okay. This energy content per period is finite. Okay. And the unit power of this signal need to only be calculated over the period. Okay. Okay. So that means if you calculate the energy of a signal with one period, so you can get the power actually. So that is the concept. Okay. If you evaluate this, the energy of this signal over a period, you can get the power. Okay. So you can use that integration. You can use the integration to calculate. Okay. 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 So if you want to evaluate the power of this signal, VT, don't worry. Okay. This will not come to exam. Okay. I'm just reminding. Okay. 20 to 500T. This is your signal. Okay. And if you want to find the power of this signal, you have to evaluate this within one period. That means period means one fundamental, one cycle, within one cycle from here to here. 0 to 0.01, 0.01, and you need to get this cos to 500T, and you need to square this. Okay. And you need to evaluate this. Okay. So you need to evaluate this integration. Okay. To find the power of the signal. Okay. So try to evaluate this one. Okay. So once you evaluate this as the power, you will get, okay. So once you evaluate this as the power, you will get the square of this amplitude should be divided by 2. Actually, this is the power of a sinusoidal signal. That is, if you square the amplitude and divide it by 2, you can get the power. Okay. So you can remember this one. This is how we can find the power of a sinusoidal signal. This is the power of a sinusoidal signal. Using this one, you can calculate the power. So if a sinusoidal signal is in this form, cos omega t plus phi, this A is the amplitude. So power is nothing but amplitude square divided by 2. This is the power of a signal. හරි මේක තමයි power එක signal එක. දැන් මේවා simple දේවල් මතක තියාගන්න. හරි. මතක තියාගන්න idea එකක් තියාගන්න. This is how we can calculate the power. A square divided by 2. This is the power. This is the power. Okay. Okay, this is the power. And so you can calculate the power of this signal, of this sinusoidal signal, that is 20 square divided by 2, because this 20 is the amplitude of the signal. So you need to square it and divide it by 2. So you can get the value. Okay, so power of this signal, what is the power of this signal? 220 square divided by 2, that is 200, no? Watt. 200 watt. This is the power of the signal. If this is voltage, or if this volt, this will be 200. Okay. So what type of signal you can see the spectrum analysis? Okay. So signal power is 200 watt. Now tell me, what is the frequency of the signal? What is the frequency of the signal, of this signal? What is the frequency of this signal? You should tell it. Tell me what is the frequency of this signal. Power you can calculate using this equation. Using this equation, you can calculate. Power is equal to A square divided by 2. Okay. This is power. Using this equation, you can calculate the power. Now, what is the frequency? Now, what is the frequency? What is the frequency again? My signal again. What is the frequency of this signal? What can make frequency come back? My signal again. The my signal එක තමයි spectrum analyzer එකට දෙන්නේ. හරි? ඒතකොට spectrum analyzer එකෙන් කරන්නේ මේ වැඩේම තමයි. ඉස්සෙල්ලා යාගේ power එක calculate කරගන්න. ඊළඟට බලනවා frequency මොනවද කියලා. Now what is the frequency of this signal? You should be able to answer that question. ඒකට පුළුවන් වෙන්න උත්තර දෙන්න. මොකද frequency එක? මොකද frequency එක? මොකද frequency එක? මේ signal එකේ frequency එක මොකද? What is the frequency? This is 20 cos 2500 t. This is a sinusoidal signal. Only one frequency component or one harmonic. And what is that frequency? What is the frequency? Tell me quickly. We need to proceed. I've got to get frequency. Tell me quickly, what is the frequency? To proceed further.
Okay.
Yes. Yes, thank you. That is 100. Okay, thank you for the answer. The frequency is 100. The frequency is 100. This is a frequency, okay? This is a frequency, 100, okay? So now you have the power and you have the frequency. So what is plotting in the spectrum analyzer? Frequency versus power, okay? So frequency is 100. The corresponding power is 200 watt. Actually, this is plot in the spectrum analyzer. So this kind of things you can see. Actually, this is not like this. So you will see this kind of signal in the spectrum analyzer. So this kind of thing you can see in the spectrum analyzer. Okay, in the spectrum analyzer. So one frequency component is there corresponding what? Okay, so you can do this. You can check this at the lab. Very easy. So if you come to the lab, I can give you these equipments. Okay, one signal generator and spectrum analyzer. Then I can ask, you can set the value and you can set it to the, feed it to the spectrum analyzer and you can check this, okay? So you have the labs, okay? And any times you can use these labs, not any times, but you can come to the labs and you can use this, okay? ඔකට lab වලට ඇවිල්ලා මේවා lab වල පාවිච්චි කරන්න පුළුවන්, හරි? හරි? මට ඇවිල්ලා කිව්වොත් එහෙනම් මට මේ equipment අරන් දෙන්න පුළුවන් ඔකට lab එකෙන් කොහොමද හරි වෙලා කරන්න කියලා. lab එකේම. හරි? කට්ටිය නැති වෙලාවක. හරි? එතකොට මේ ඒවා එතකොට ඔකට බලන්න පුළුවන් මේවා ඇත්තටම. හරි? මේවා මේ මම කියන විදිහට වෙනවද නැද්ද කියලා. හරි? Okay. Okay. So actually this is okay. So this is just the frequency domain representation. This is the frequency domain representation. Okay? We represent power with respect to frequency. And here it is a time domain representation. The time with respect to voltage with respect to time. So this is time domain signal and this is frequency domain signal because the independent variable is here frequency, okay? So actually this transformation is done by Fourier analysis, okay? Fourier analysis, okay? So that is the function of the Fourier analysis, okay? So you can see the, so we will again move to the Fourier analysis, that is chapter 5, continuous time, okay? Continuous time Fourier analysis, okay? And you can see this spectrum introduction, you can read this, okay? If you have any problem, you can ask, okay? So these are the definition for the periodic signal, okay? And this is a sinusoidal signal representation. This is a complex signal representation. These are periodic signals, okay? These are periodic signals. Okay. So here, complex exponentials Fourier series representation. What does that mean? Any continuous time signal can be represented as a sum of complex exponential term. Complex exponential term E j k omega naught t. So this omega naught is the fundamental period that is equal to 25 t naught. T naught is the fundamental. Omega naught is the fundamental period. T naught is the fundamental period. Omega naught is the fundamental frequency. This is fundamental frequency. T naught is the fundamental period. Okay. So you can represent any signal as a collection of complex exponential terms. In other way around, what is this? You can represent any signal. So this a complex exponential signal has only one frequency component. That means only one harmonic. Okay. So you can represent this signal as a collection of harmonic, as a sum of harmonic, as a sum of different frequency components. So any signal can be represented like this, any periodic signal. Okay. And so this complex harmonics is multiplied by a weightage that is we called complex Fourier coefficients. And you can use this identity to calculate the Fourier series coefficients. Okay. Okay. And this is the zeroth coefficients you have to calculate. Okay. And so likewise, you can evaluate the things. Okay. Okay. So you can use in these two equations, these three equations. Okay. You can represent any periodic signal. Okay. Any periodic signal. Actually, there is a condition that is called distinct condition. I can't remember. Okay. Okay. So that condition should be satisfied, but almost all the practical signals satisfy that condition. Okay. So it is okay to set that any signals can be represented. Okay. It is okay to set that any signal can be represented because the most of signals satisfy that condition. Here that condition is mentioned, I can't remember. That is called Dietrich condition or something. Can anyone remember? Can't remember that is all okay. Um, see. So, Dirichlet. Okay. This condition, okay, I can't read it. Dirichlet. Okay. This condition. So this is called Dirichlet, no? Dirichlet condition. Okay. Okay. So, so this condition, this Dirichlet condition should be satisfied, and this condition should be satisfied if we want to represent that signal using the Fourier series representation. Okay, so most of signals, okay, most of signals will satisfy this district condition. Most of signals we are coming across. Okay, the practical signals we are mainly practical and mathematical signals we are mainly deal with satisfy the Dirichlet condition. Okay, so it is okay to say every signal. Okay, so most probably I will say any signal. Okay, so that is correct up to some level. Okay, I hope you can understand. Hari mama සාමාන්‍යයෙන් කියන්නේ any signal කියලා. any signal කියවර ප්‍රශ්නයක් නැහැ. අර condition එක හැම signal එකකම වගේ satisfy වෙනවා. හරි. Okay, so a signal, okay, a signal that satisfy those conditions can be represented as a collection of harmonics using this equation. Okay, using this equation. Okay, so I will write it here. Okay, so I told you that Fourier series, Fourier analysis, you have two parts, Fourier series and Fourier transform. In Fourier series, you have complex exponential Fourier series representation. Okay, so continuous time signal, you can represent continuous time signal, you can represent as a collection of complex exponential signal. Okay, minus j omega naught t, j is there. Okay, and there is a weightage. Okay, this is not plus. Okay, this will be plus. Okay, so you can represent any signal, any periodic signal. So this is for periodic signal. Okay, this is for periodic signal. This is for non-periodic signal. Non-periodic signal. So any periodic signal can be represented using this summation Ck e to the power jk omega naught t. Okay. Okay. And this k from minus infinity to plus infinity. And k should be an integer. K should be an integer from minus infinity to plus infinity, including 0. Minus 1, minus 2, minus 1, 0, then 1, 2, 3, likewise, this infinity or minus infinity. So this is the integer. And this omega naught is a fundamental period, and it is given fundamental frequency. It is defined as full phi t naught. T naught is the fundamental period. Okay. So this is how we can represent any signal as a collection of harmonics. Okay. So you know that corresponding to this complex exponential term, there is only one frequency component. Okay. So that frequency component is multiplied by k. Okay. So there are different frequency components. Okay. So there may be different frequency components. Okay. So we can represent this signal as a summation of this kind of complex exponential terms, and we can find the frequency component actually. Okay. So this is one frequency component. Okay. Or one harmonic. Okay. So using this, we can represent any signal as a collection of harmonics actually. As a collection of harmonics. That is the idea. Okay, that is the idea. And you can evaluate this Ck using this integration 0 to t naught. The integration you should do within a period. Okay, and you need to get signal multiplied by minus jk omega naught t dt. This is how you can evaluate the Ck value. Okay, So using these two identity, you can represent any signal, any continuous time signal. This is for continuous time. Continuous time. This part will not come to our side, our calculation, okay? But you need to have this idea. This is for continuous time. This will come. This will evaluate for continuous time. Okay? This identities we use for continuous time period. Okay? Now if I get one solved problem, okay? Actually here we no need to do questions, okay? Because that part is not mainly covered in our one, okay? So let's consider this kind of signal, okay? This kind of signal. Okay, now tell me, this is a periodic signal or non-periodic signal? Is this signal is periodic or non-periodic? Please tell me. If you consider this signal is periodic or non-periodic? Tell me. Make a periodic signal එකක්ද non-periodic signal එකක්ද? ටක් ගාලා කියන්න. නැත්නම් අපිට යන්න අමාරුයි. පුළුවන් උත්තරයක් දෙන්න. දන්න විදිහට උත්තර දෙන්න. හරි? If your answer is wrong, no problem. හරි? I don't care, but I need the answer. I need the answer. Is this periodic signal or non-periodic signal? Just see and tell me. You know what is periodic. Periodic means repeating. Okay? And also you know what is non-periodic. Non-periodic means it is not repeating. Okay? So check this signal is repeating or not. Okay? So tell me, is this a periodic or non-periodic? මෙයා repeat වෙනවද කියලා බලන්න මේ signal එක. දැන් මෙයා යනවා දිගටම. මෙතනින් ඉවර නැහැ මේක කොහොම යනවා. හරි. මේ පැත්තටත් මයිනස් පැත්තටත් මේ සිග්නල් එක තියෙනවා. ඉතින් ඔය කොහොම පෙන්වන්න බෑනේ කොහොම අනන්තයට යනකම්. ඒකින්ද තමයි මේ පොඩ්ඩක් පෙන්වන්නේ. මේක හරිනම් කොහොම ටික ටිකක් තියලා තියන්නේ. හරි. right මට කියන්න මේක periodic ද non periodic? Tell me, is this periodic or non periodic? Quickly tell me. මේ ගණන් හදලා ඇත්තේ අනිවාර්යයෙන්ම signal and system වලට මේ ගණන් හදලා ඇති. Yes, that is periodic signal. Thank you. Okay. Thank you for the answer. Try to give your answer quickly. Okay. Okay. So this is a periodic signal, definitely. This is a periodic signal. Okay. Because you can see that this signal is repeating. So you can see that this part is repeating here again. And here it is again repeating. Okay. So this is repeating signal. And what is the period? What is the period? Quickly tell me what is the period of this signal. මෙයාගේ period එක මොකක්ද? Quickly tell me. Yes, it is periodic. So what is the period of the signal? Thank you for the answer. What is the period of the signal? It's a periodic signal, and what is the period? Quickly tell me, what is the period? Just see how you calculate it. How to find the period? The time between two consecutive repeating points. The time between two consecutive repeating points. What is the period of this signal? How to find the period? You need to select two consecutive repeating point and check the time. So this point is repeating where? This point is repeating where? කියන්න බලන්න. මේක එක, මේක දෙක, මේක තුන. So tell me this point is repeating at 1, 2 or 3. මෙයා repeat වෙන්නේ මෙතනදිද මෙතනදිද? It is 2. Very good. Okay. So this point is repeating here. So to period means the time from here to here. The time from here to here. So what is the time from here to here? What is the time from here to here? What is the time? These are time values, okay? Because this signal is plotted with respect to time. This signal is plotted with respect to time, okay? So these are time values. Yes, that is the time, okay? T naught minus 0. That is the time. T naught minus 0. So what is the time? T naught. This time will be T naught. This point is repeating after T naught. So what is the period? What is the period? This point is repeating after T naught. That means what is the period? That is the consecutive. Oh no, not one. No. This is a continuous time signal. This is continuous time signal. This is a continuous time signal. So the period should be in time, not in sample. If it is a discrete time signal, you are counting the sample value. But this is continuous time signal. හරි? ඒක මතක තියාගන්න continuous time signal එකක් හැම වෙලාවෙම time එක. Period එක time එක second වලින් එන්නේ. Discrete time signal එක නම් period එක second වලින් නෙවෙයි අපි කියන්නේ sample number එකකින්. 1ද 2ද 3ද කියලා. හරි? දැන් මෙයාගේ time එක කීයද මෙතන ඉඳන් මෙතෙන්ට? මෙයා repeat වෙන්නේ time එක කොච්චර second වලට පස්සේද? If this t is measured in second, මෙයා repeat වෙන්නේ කොච්චර second වලින් පස්සේද? 1 second ද? 1 second ද නෑනේ. මොකද්ද? මේ time දාලා තියෙනවා. මේ time දාලා තියෙනවා. මෙයා බිංදුව මේ t naught second. එතකොට මෙයා ආපහු repeat වෙන්නේ කොතනින්ද? මෙතනදී. ඒ කියන්නේ කොච්චර කාලෙකද? මෙයා ආපහු මෙතෙන්ට එන්නේ. What is the time? Yes, that is T naught. Okay. So the time is T naught. That is the fundamental period. T naught. T naught is the fundamental period. Okay. Now you can find the fundamental period T naught. So this is a periodic signal. Okay. So that signal xt can be represented as a sum of these exponential terms, this kind of exponential term. Okay. Okay. And you need to evaluate the CK value. You need to evaluate this CK value. Okay. So CK value you can evaluate using this integration. Okay. So they have do this integration and finally get the value. So you can see the value here. This is the value you get for CK. Okay. This is the value you get for CK. Okay. And the value for C naught is this one, A divided by 2. Okay. Okay. So you have, so they have find a value for CK. Okay. So that is this value, A divided by JK to 5, 1 minus 1. Okay. So this is the value for CK. හරි මේක තමයි CK වලට එන value එක. හරි C බිඳුව ඇවිල්ලා තියෙනවා A by 2. This is C now. So if you want to find C1, what you have to do? C1 means K is equal to 1. So you can apply 1 here. So A divided by J125, 1 minus 1, this is K also 1. So 1 minus 1, it will be 2. And this 2 to cancel out. For J, you will have A divided by J to J5. This is C1 value. Same way, you can calculate C2 value if you need C2 value. Okay. So what you have to do? Instead of this K, you can apply 2 here. And here also you can apply 2. Right? Then that value will be J2 to 5, 1 minus 2. 1 minus 2. Okay. So this will be minus 2 square. So it will be plus 1. No? Minus 1 square. That will be plus 1. Minus 1 multiplied by minus 1. Minus 1 වලින් අඩි කරපුවාම එන්නේ plus 1 නේ. ඍණ ධන value එකක් එන්නේ. හරි? 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 දැන් මම C2 හෙව්වොත් හරි? C2 හෙව්වොත් මෙන්න මේකත් හරියට තේරුම් ගන්න. තේරුම් නැත්නම් පස්සේ හරි මගෙන් ඇවිල්ලා අහන්න මේක කොහොමද කියලා. මේක වෙන්නේ මොකද්ද කියලා දැන් මෙතනදී තේරුම් ගන්න බලන්න. සාමාන්‍ය මට්ටමකට තේරුණා නම් ප්‍රශ්න අහලා ඒක ක්ලියර් කරගන්න. If you couldn't දැන් ප්‍රශ්නයක් අහන්න තරම්වත් තේරුන්නේ නැත්නම් පස්සේ ඇවිල්ලා මාව හම්බෙලා අහන්න. හරි? අහගත්තොත් පුළුවන් වෙනවා. හරි? අහගත්තොත් පුළුවන් වෙනවා. අහගත්තේ නැතුව හිටියොත් ඕක හැමදාටම බෑ. හරි? හරි? Then if you want to find C2, what you need to do? You can apply 2 here. Instead of this K, you can apply 2. So I will have A divided by. So there can be some value for this A. Okay. Okay. So that is the amplitude of the signal. Okay. So practically, this may be 2 volt, 3 volt, 4 volt, or some kind of value. Okay. Okay. This A. Okay. Now it get a general value. Okay. Then mark common value arrogant here. Okay. Now J. K is equal to 2 and 2, 5 is there. Okay. Into So you can see that 1 minus minus 1 is square. K is equal to 2. No? Now you are measuring C2. K is equal to 2. C2. Okay. So you can calculate the C2 also here. What is the C2? So this will be minus 1 square. So minus 1 square will be plus 1. So 1 minus 1. So that will be 0. So C2 will be 0. Okay. In the same manner, you can find C3. What is how we can measure the C3? So instead of this K and this K, you have to apply 3. Correct? මෙතෙන්ට 3 දාන්න. K වෙනුවට 3 apply කරන්න දෙන්න. Instead of this K, you have to apply 3. Okay? මේ K වෙනුවට මෙතෙන්ට 3 දානවා, මෙතෙන්ට 3 දානවා. හරි? So you will have A, J. Now K is equal to 3. 2, 5. 1 minus minus 3. Okay? So what is the value? What is minus? Minus 1 is square. What is the value? Minus 1 is minus 1/3. What is the value? What is this value? What is the answer for this? කියන්න බලන්න මේකට මොකක්ද answer? No. That is wrong. Minus 1, 3. That means මොකක්ද? minus 1 වැඩි කිරීම minus 1 වැඩි කිරීම minus 1 වැඩි කිරීම නේ. minus 1 වැඩි කිරීම minus 1 වැඩි කිරීම minus 1. දැන් අපි A වල 4 කියලා ගත්තොත් එහෙනම් ඒ කියන්නේ A වැඩි කිරීම A වැඩි කිරීම A වැඩි කිරීම A 4 පාරක් වැඩි කරලා. ඒක තමයි A 4. No, that is also not the answer. This is the answer. minus 1 වල 3 වෙනි බලය කියන්නේ මොකද්ද? ළමයි මේ basic mathematics වල කට්ටිය චුට්ටක් touch කරන්න හරි. මේ ඒක කට්ටියට වැදගත් හරි. ඉතරලා දාන්න එපා මේක. හරි. මේක ප්‍රශ්නයක් මත මේ කියන්නේ කට්ටියට අමතක වුණා කියලා අවුලක් නැහැ. මේ මම මෙයා දර්ශකයක් ගන්න. හරි. මේ 7 වසරේ 8 වසරේ ඉගෙන ගන්නවා very good. That is minus 1. Okay. මේ 6 7 වසරේදී ඉගෙන ගන්න දේවල් හරි සමහරට ඔය කට්ටියට අමතක ඇති. මොකද ඔය කට්ටිය සමහර කට්ටිය මැත්ස් කරලා නැහැ මේ A level කාලේ. හරි. එතකොට මේවා ටිකක් අමතක ඇති. ඒ වුණාට දැන් ඔය කට්ටියට ආපහු මේවා මතක් කරගන්න වෙනවා. හරි. මේ බේසික් දර්ශක ලඝු ගණක සාධක හරි. ඊට පස්සේ නිකිල අඩු කිරීම එකතු කිරීම සරල සමීකරණයක් විසඳන හැටි සමගාමී සමීකරණ විසඳන හැටි හරි. ඒ ටික දැනගන්න වෙනවා. ඊට පස්සේ අර බේසික් ට්‍රිගොනොමෙට්‍රික් දේවල් ත්‍රිකෝණමිතිය tan θ cos θ sin θ ඒවා කොහොමද මේවා කරන්නේ? ඒ වගේ දිගවල් කොහොමද මනින්නේ ඒ ටික. හරි. ඒ ටික පුරුදු වෙන්න ඕන. ඊට අමතරව බේසික් ඉන්ටග්‍රේෂන් සාමාන්‍යයෙන් අනුකලනයක් කරගන්න හැටි අවකලනයක් කොහොමද කරගන්නේ? අන්න ඒ ටික ඔය කට්ටිය අනිවාර්යයෙන්ම පුරුදු වෙන්න ඕන. හරි. ඔය කට්ටියට ඉස්සරහට යන්න නම් ඒ ටික ඕන. හරි. ඒ කියන්නේ ඔය කට්ටිය දැන් සමහරට ඔක කරලා ජොබ් එකක් කරන්න ওই ටික ඕන වෙන්නේ නැති වෙයි. හරි. ජොබ් වලට ගියපහම ඕවා කොහොමදත් ඕන වෙන්නේ නැහැ. අවකලනය අනුකරණය කරන්න වෙන්නේ නැහැ ජොබ් වල. හරි. ඒ වුණාට මෙන්න මේ අයිඩියාස් පොඩ්ඩක් තියෙන්න ඕන. හරි. නැත්නම් මේවා යම් කිසි තැන්වලදී ඇප්ලයි කරන්න වෙනවා. හරි. ජොබ් කරනකොට. අර කට්ටිය ඇත්තටම ජොබ් එක නිකන් ටෙක්නීෂියන් ලෙවල් එකකට වගේ නෙවෙයි යන්නේ. ඔය කට්ටිය හුඟක් වෙලාවට යන්නේ ඇසිස්ටන්ට් ඉංජිනියර්, එක්සිකියුටිව් ඉංජිනියර්. හරි. sorry. ටෙක්නිකල් එක්සිකියුටිව්. ටෙක්නිකල් එක්සිකියුටිව් කියන ජොබ් වලට ඔය කට්ටිය අරන් තියෙනවා. ටෙක්නිකල් එක්සිකියුටිව් කියන්නේ සාමාන්‍ය ටෙක්නිකල් ඔෆිසර්ට උඩින් තියෙන ජොබ්. සාමාන්‍යයෙන් ජොබ් අපි යන්නේ. හරි. මේ එකක්වත් නරක ජොබ් නෙවෙයි. හරි. These are not bad jobs. Okay, all are very important and very professional job. So normally engineering we have labor. That is also a good job. Okay, make a hunda job. Ek naraka job ekak නෙවෙයි. But there are very high load with low salary. Right? If you are a labor, you have to do a lot of work for a low salary. Right? හැබැයි වැදගත් ජොබ් එකක්. හරි. That is a very important job. Okay. The respectable job. Okay. Labor කියන්නේ එක්තරා විදිහක respectable job එකක්. හැබැයි වාට වැඩ ගොඩක් කරන්න වෙනවා අඩුපඩියකට. That is labor. මේවා නරක job නෙවෙයි. හරි. අපිට මේවා නරක job කියලා කියන්න බෑ. හරි. Then there is another called skilled labor. Okay. Skilled labor. Okay. That means you have some skills here. So මෙයා ඉන්නේ නිකන් technician උයි labor අතර වගේ. හරි. සාමාන්‍ය මේකට බාස්ලා කියලා කිව්වත් කමක් නැහැ මේකට. සමහරවිට බාස් කියලා කියනවා. සමහරවිට බාස් කියන එක ටෙක්නීෂියන්ටත් යූස් කරනවා. හරි. ඒව හරියටම ඉරක් ගාලා වෙන් කරන්න බෑ අපිට. හරි. So skilled laborers, they are actually professional guys. Okay. These are professional guys. Okay. Skilled labor means these are professional guys, but still you have very high load of work, low salary. Hari. ගොඩක් වැඩ කරන්න තියෙනවා අඩුපාඩියකට skill එක. But professional. Okay. This labor is not a professional. You don't need any skills to do. මේ job එක කරන්න skills ඕනේ නැහැ. හරි. ඕන මිනිස්සුෙකුට ගිහලා කරන්න පුළුවන්. ඒක හැබැයි ඒක respectable job එකක්. No need skills. වැඩ වැඩි පඩියක්. හරි. skill labor යම් කිසි මට්ටමකට පඩිය වැඩි හැබැයි වැඩ වැඩි. හරි. Then we have technician. This is also a professional guy. Very important guy. Okay. Technician. After that, so skilled labor technician, මේ දෙක අතර තමයි සාමාන්‍ය බාස් කියන එක කියනවා ඉන්නේ. හරි බාස්. Technician කියලා කියන්න පුළුවන් බාස්. හරි. Then we have technical officer. Okay. Technical officer. This is a good job. Okay. And sometimes low works there. Normal high salary. You can get a high salary for a TO. Okay. Then technical executive, senior technical officer, technical executive. Okay. An assistant engineer, senior engineer. So this is how we have jobs. Okay. So all these are from here. These are professional job. May come a professional වෘත්තීය jobs. Hari වෘත්තීය වැඩ. So you need these skills. Okay. For a technician, you need these skills, definitely. Okay. Maybe you don't need to mathematical things. Okay. So if someone show you the fault, sometimes technician also will find the fault by himself and repair it. Okay. And TO also actually not doing the things, but he managing the things. Okay. So he is in managing position up to some level. Okay. So TE also technical executive. These are also some management things. Okay. So maybe some of you guys is starting here. Some of you guys is starting here. Some of you guys is starting here. Okay. So most of you guys may be starting in this positions. Okay. So for this position, you need also some management skills also. Okay. For that one, you need to have some mathematical skills. Okay. Sometimes technician may be asked from you. Right? What is this? Then you have to explain it. Okay. So you are starting your career in this level. Okay. So please try to learn at least the basic things. Okay. If you have any help, we can help you. Okay. So these are very important jobs actually, without very so you no need to do much work, but you can get a good salary in this level. Okay. Okay. Actually, I also start from here. Actually. My career is start as a technician. Maybe 3 months I was there as a technician. Okay. Then I come all these levels. Okay. Technical executive is not in my career. Technician, TO, assistant engineer, senior engineer, and manage up to that level. I could come. Okay. I'm starting here with the certificate course, City and Guild certificate. Okay. Okay. So anyway, you need to have that mathematical things. So you need to try to understand them also. Okay. Okay, that is not related with our course. Okay. So what is this? -1 into 3. That means -1 into -1 into -1. -1 වැඩි කරනවා -1 වලින් වැඩි කරනවා -1. Can ban minus 1 වලින් අඩි කරපුවාම කීයද? minus minus plus 1. ආපහු plus 1 වැඩි කරනවා minus 1. එතකොට කීයද එන්නේ? 1 minus 1. So plus minus. So you will have minus 1. Okay. So this will be minus 1. This will be minus 1. So this will be minus 1. Minus 1. So minus minus again it will be plus. So 1 plus 1 that is 2. So you will have 2a j 3 2 5. This is for C3. Okay. In the same manner, you can calculate C4. Try to calculate C4. It will be 0 definitely. Okay. So try to calculate. Okay. And also if you need, you can calculate C minus. C not already calculated. Okay. In the same manner, you can calculate C minus 3. So you have to apply minus 3 here and minus 3 here. C minus 2. You can apply minus 2 and minus 2 here. C minus 1. You can apply minus 1 and minus 1 and minus 1 here. So you can calculate these things also. If possible, try to calculate these values. Okay. So now you can calculate these values. Okay. So finally, you can represent this signal as a sum of collection. This kind of, okay. So you can represent this signal xt as a collection of this sinusoid complex exponential signal. Okay. So k can be from minus infinity to plus infinity. Okay. So you can apply any k value, maybe 1000k. Likewise, you can apply. Okay. Then you can calculate these values. Okay. And so C3, if you calculate C3, that is k is equal to minus 3. Okay. So you will have C minus 3 e to the power j. K is minus 3 omega naught t, this value. If it is C minus 2, that means k is equal to minus 2 e to the power j minus 2 omega naught t. Okay. Plus C minus 1 e to the power j minus 2 omega naught t. Plus C0 e to the power j, k is 0 omega naught t. So on you can write. Okay. Okay. So for this signal, okay, this signal, that periodic signal, when මේ signal එක හරි මෙහෙම තියෙන signal එක හරි මෙයා A මෙයා T node මේක තමයි signal එක හරි periodic signal එක. Okay. You can represent this signal, this is xt, okay, as a collection of complex exponential terms. Okay. So k, okay, as a collection of complex exponential k from minus infinity to plus infinity, ck e to the power plus jk omega naught t. Using this one, you can represent this xt as a collection of complex exponential terms. Okay. So this k can be from minus infinity to plus infinity. Okay. So here we have calculated C minus 3 e to the power C minus 3 අත්තර මම calculate කරේ නෑ. උනාට calculate කරගන්න පුළුවන්. හරි. මෙන්න මේ equation එකට මේ equation එකට minus 3 දාන්න තියෙන්නේ. එතකොට C minus 3 වලට එනවා value එකක්. ඒ වගේම C minus 2 බලන්න. C minus 1 බලන්න. C not already calculated. C1 already calculated. C2 already calculated. C3 already calculated. And also C4 also can be calculated. Okay. So you can represent like this. Okay. So C0, C3 e to the power j, k is minus 3 omega naught t plus C minus 2 e to the power j minus 2 omega naught t, because k is equal to 2. K is equal to 2. Now k is equal to minus 1. Minus 1, k is equal to minus 1, e j, k is equal to minus 1 omega naught t. Okay. Plus now k is equal to 0 e to the power j 0 omega naught t. Then C1 we have calculated. E j k is 1 omega naught t. C2, we have calculated E J2 omega naught T plus C3 E J3 omega naught T. ඔය වගේ ලියන්න පුළුවන්. හරි. දැන් මේ සිග්නල් එක ලියලා තියෙනවා some complex exponential signal වල එකතුවක් විදියට. මම මෙයාව expand කරනවා. හරි. මේ එකතුවක් නෙමෙයි මෙතන තියෙන summation එක. මම මේ expand කරලා ලියනවා මේ signal එක. හරි. එතකොට මට මේ C value අර තිබ්බ calculated value වලින් මේව කරගන්න පුළුවන්. හරි. එතකොට මේ calculated value වලින් වැඩි කරලා මෙන්න මේ වලින් add කරලා කොහොම මට මෙන්න මේ signal එක එන්න ඕන. හරි. මේ signal එක එන්න ඕන. එතකොට මේ C3 C2 C-1 C1 C2 C3 ඒව calculate කරගන්න පුළුවන්. I can calculate using this identity. මෙන්න මේ identity එක පාවිච්චි කරලා. හරි. මෙන්න මේ identity එක පාවිච්චි කරලා අර value calculate කරගන්න පුළුවන්. හරි. ඊට C note එකත් calculate කරලා දෙනවා. ඒ බෙදීම දෙකයි. හරි. C notes වල එන්නේ ඒ බෙදීම දෙකයි. හරි. ඒ වගේම C1 C2 එහෙමත් calculate කරගන්න පුළුවන්. හරි. hello. okay. හරි. දැන් මේ විදිහට ලියා ගන්න පුළුවන් මට complex exponential terms වල එකතුවක් විදියට. right. මට කියන්න බලන්න what is the frequency component of this signal, this part? What is the frequency component of this part? මෙයාගේ frequency component එක මොකද්ද? මේක තමයි frequency එක නේ. -3 omega naught. -3 omega naught. දැන් මේ omega naught කියන එක fundamental period එක. ඒක සමහරට 100 වෙන්න පුළුවන්, 50 වෙන්න පුළුවන්, 60 වෙන්න පුළුවන්, 70 වෙන්න පුළුවන්. එහෙමනම් මෙයාගේ frequency එක එන්නේ -300. මෙයා omega naught 100 කියලා හිතන්නකො. මෙයාගේ frequency එක එන්නේ -300. -3 omega naught. What is the frequency of this one? -2 omega naught. omega naught කියන්නේ 100 නම් -200. මෙයා එන්නේ -1 omega naught. ඒ කියන්නේ omega naught කියන්නේ 100 නම් මෙයා එන්නේ 100. -1 omega naught. Okay. What is the frequency component of this signal? මට කියන්න බලන්න මේ signal එකේ මොකද්ද frequency component එක? What is the frequency component of this signal? What is the frequency component of this signal? Tell me. What is the frequency component of this signal? C naught J0 omega naught T. This is the zeroth coefficients. This is we called complex Fourier series coefficients. Complex Fourier series coefficients, and this is the zeroth coefficients. මොකක් හරි උත්තරයක් කියන්න. හරියට තුනත් එකයි වැරදුනත් එකයි. මෙයාගේ frequency component එක කීයද? Yes, that is very good. Okay. So that is the frequency component. Okay. So what about others? Chetana, what is the frequency component? What is the frequency component here? What is the frequency component? What is the frequency component for this part? මෙයාගේ තියෙන frequency එක කීයද? දැන් මේ මම කියවා මේක complex exponential terms එකක්, repetitive signal එකක්. හරි? හරි? E J omega naught t. මේ කියන්නේ මෙයා plus or minus. මේක complex exponential signal එකක්. මෙයාව අපිට ලියා ගන්න පුළුවන් ඇත්තටම Euler formula එකේ මේ විදිහට. J sin omega naught t. දැන් මෙයාගේ තියෙන omega naught මෙයාගේ omega naught. ඒ කියන්නේ මෙයාගේ frequency component තියෙන එකයි omega naught. හරි? එහෙනම් මේ periodic මෙන්න මේ signal එකේ frequency component එකයි මේක තමයි frequency component. ඒක තමයි harmonic එක. හරි? දැන් මට කියන්න මෙයාගේ frequency component එක මොකක්ද? value එක. This is the frequency component. What is that? This is J0 omega naught t. This is the frequency component. What is that? 0 multiplied by omega naught. What is the frequency component? So it is 0, no? Okay. Yes, thank you. It is 0. Okay. So this signal, this part has 0 frequency component. What that means? What is 0? Frequency is 0 means what? What is this signal? If this is 0, what is this signal? There is no frequency. Frequency is 0. That means what is that? So if you turn on your power supply and if you measure the value using the voltage, you can get this kind of value. Okay. So what is this value? Is this DC or AC? Yes, this is a DC value. This is a DC value. Okay. So for a DC value, so what is the frequency here? The frequency is 0, no? So this is DC. DC means frequency is 0. So frequency is 0 means this is DC. So what is this actually? This is the DC component. This is the DC component of the signal. This is the DC component of our signal. Okay. So that is A divided by 2. Okay. So this is it. Okay. Actually, practically you can see this. Practically we can see this. Okay. Using MATLAB we can see this. Okay. So I will use MATLAB. Actually I have written one program, so I will show that program to you. Okay. So anyway, if you need MATLAB, you can go to the IT department and get the program, okay, from Mr. Manu, okay. So if you need MATLAB, please go and collect because you need to have some MATLAB skills also when you complete this, okay. After you complete this, you should have some MATLAB okay, so we can see it using MATLAB, okay. So if you couldn't understand this, please come and ask me, okay. මේක තේරුණානේ මේ මොකද්ද කරේ කියලා මේ කතන්දරේ තේරුණානේ අපි රිප්‍රසන්ට් කරේ මෙයාව Fourier series පාවිච්චි කරලා complex signal වල එකතුවක් විදියට ලියවා. complex signal එකක් කියන්නේ එක harmonic එකක්. මේක complex signal එකක් කියන්නේ එක harmonic එකක්. complex exponential එකක් කියන්නේ. ඒ කියන්නේ මේ signal එක අපි harmonics වල එකතුවක් විදියට ලියුවේ. හරි? හරි? Okay. So that is what we have done, okay. මේ signal එක අපි harmonics විදිහට ලියාගත්තා. හරි. දැන් අපි බලන්නේ මේ වගේ parts ටිකක් එකතු කරපුවම මේ signal එක හැදෙනවද කියලා. හැදෙන්න ඕන නේ. මෙයා අපි මෙයාට decompose කරගත්තා නම් මේ ටික එකතු කරපුවම මේ signal එක ආපහු හැදෙනවා. දැන් අපි බලන්නේ ඒක හැදෙනවද කියලා. හරි. අපිට පුළුවන් MATLAB වලින් මේ signal මේවා එකතු කරන්න. මේ parts එකතු කරන්න. හරි. So I have wrote one MATLAB MATLAB so we need to develop this one also, the discrete time Fourier series. Actually, this is the program I have developed. Okay, so that is very simple program. Okay, so I will explain how to code this. Okay, so this is the clear CLC and clear all. So you know what is this command. Okay, this is for clear this workspace variables and this command window variables. Okay, so you can use this command. Okay, so now you can see that. Okay. Now you can see that this signal is a time domain signal. This signal is a time domain signal. Okay. So now the period is measured in T naught. Okay. But we need to give some real values to grow the signal. Right? Signal like a broker and real values then no. And we need to give some time values. Okay. Some time intervals to draw the signals. Okay. So I have given some time intervals. Okay, I have given some time intervals. So I select them according to the period. Okay, according to the period. Okay, so there are 0 to 1. I get time samples. Okay, so this is the increment I get because this increment should be very low. Why? Because we are going to draw continuous signal. හරි continuous signal එකක් නම් මේ point එක එක ළඟ තියෙනවා. එතකොට තමයි ඒක අපිට continuous වගේ පේන්නේ. නැත්තම් නිකන් හරියට එන්නේ නැහැ හැටි. හරි? So I have selected very small increment. Okay, so this is used to define my time values. Okay, so if I run this, I can get some time value here. Okay. So if I run, I will comment this. Okay. Now if I run this, okay. So you can see that I got some time values. So I get 1001 time values. Okay. So these are the times I select. Okay. These are the time values. Okay. Now I have to define the omega naught. Okay, so that is the fundamental period. So I select it as 8. You can select it any point. Okay, so I select this as omega naught. Okay, so this is I select minimum and maximum. That is the value. Okay, that is the value I am going to calculate. Okay, so here you need to add them together. No? These are the coefficients. First, you need to calculate the coefficients. Okay, so you can calculate the coefficients using this identity. CK කියන එක calculate කරගන්න පුළුවන් මෙන්න මෙයාගෙන්. හරි? මෙන්න මෙයාගෙන් හරි මෙයාගෙන් හරි. අත්තරම මම මෙන්න මෙයාවද කොහෙද plot කරලා තියෙන්නේ. හරි? දැන් මෙයාගෙන් අපිට පුළුවන් මෙයයි මෙයයි දෙකම සමානයි. This one and this guy is equal. Okay, so you can code this one or this one to calculate the CK value. Okay, so I have coded it. හරි? හරි? Okay, දැන් මම code කරලා තියෙනවා මේක. හරි? මෙන්න මෙතන code කරලා තියෙන්නේ. මෙතන CK. හරි? I have code this one. Okay, so CK. Okay, so actually here I haven't defined the A. Okay, so you can define the A here. That is the amplitude. So amplitude may be 2 volt, 3 volt or anything. Okay, So that is the amplitude. And this amplitude, this should be amplitude here. It should be amplitude A. Okay. Amplitude. So here I use minus. Why I use minus? Because you can see that here 1 minus exponential. But here I write exponential minus 1. Correct? එතකොට මෙතන මයිනස් එක එළියට අරන් තියෙන්නේ. හරි? දැන් මේකම ටයිප් කරනවා. දැන් මේක මම ලියලා දෙනවා A divided by J. J I write like this. 1 9. So this is J. Okay. K 2 5. Okay. So I have written this equation. Okay. Now I write this as okay 1 minus C. So I get this minus. So if this is confusing, so you can remove this minus here. So you can write like this. It should be 1 minus 1. It's okay. So now that is okay. No, A divided by J. This is J. Okay. This is J. 1 I. Okay. So normally we can use I or instead of J. Okay. I instead of J. So if you use 1 I, that is good in MATLAB. Okay. And here also you can if without 1 also you can write it. Okay. But you can see that no. Now it is like this. Okay. Now it is set that. Okay. Replace complex I and J. So you can use both I and J by 1 I. So it will speed and improve the robustness. Okay. ඒක අර ස්පීඩ් එක වැඩි කරනවා සහ robustness එක වැඩි කරනවා කියලා කියන්නේ. ඒ කියන්නේ මේ I හරි J හරි වෙනුවට 1I දානවා. හරි? Okay. So you can see that. Okay. So here you can use 1I instead of J. Okay. This is instead of J. Okay. J K 25 1 minus, so exponential E. So that is coded as XEXP. Okay. Then this power you can type within the bracket. So this is minus J, that is minus 1I K 5 minus JK 5. I have coded this. Okay. So very simple. Okay. Now I have coded this. Now what I have to do? I have to calculate C minus 1, C minus 1000 maybe, C minus 10 maybe, C minus 3, C minus 4, C minus 2, C minus 1, C0, C1, C2 like this. Okay. So I am using a for loop for that one. Okay. I am using a for loop. Okay. So for this K is starting from 1. Actually, for loops, you can start from 1. Okay. So here actually without using this, okay, without using this, you can directly write here. So you can start the for loop here. Okay. So you can directly write here. Maybe, so if you start from 0, that will not, okay. 0 to some value, 0 to let's say that 2 or 1 or something. Okay. So if you start from 0, so you can see that might be missing, possibly matching for yeah, this n should be there. Okay. 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 But if we run this, okay, so you can see that it will give a yeah, I think for loop can be started from 0. As I can remember, we couldn't start. Maybe we can start from 0. Okay, so if I start it from 0, there is no any error message and it is calculated. So there should be 0, 1. That means two values should be there. But only one value is there. No? Okay. Okay, anyway, if we write here 0, the problem is that this will be 0. Okay, this will be 0. So e to the power 0. So it also will be 0. So 1 minus 1, it will be 0 actually. Okay, so you can't calculate the C naught value here. So you can calculate actually from C1. Okay, you can calculate. So anyway, you can't put minus integer here. So if you put minus, maybe it give you a wrong. It also not giving wrong, no? Actually, there is some problem because you can get only one value. Let's if I put 2 here, let's say what's okay. So actually, so you can add minus value or 0 for if you are calculating single value. Okay, if you are calculating a single value, you can add -1 or 0. හරි මේක දැන් සිංගල් වැලියු එකක් විතරක් ගන්නවා නම් ඒ කියන්නේ -1 දාලා වැලියු එකක් ගන්නවා -2 දාලා වැලියු එකක් ගන්නවා සිංගල් වැලියු එකක් ගන්නවා නම් ඕ කට්ටියට මේක දාන්න පුළුවන් හරි මෙයාව දාන්න පුළුවන් හැබැයි මෙතන ප්‍රශ්නේ තියෙන්නේ අපි array එකක් විදිහට ගන්නවා නම් මෙතන මයිනස් දාන්න බෑ එහෙම වුණොත් දාන්න ඕන ප්ලස් වල ඉඳන් වැලියු හරි දැන් ඇත්තට මෙතන මයිනස් දාන්න නැති හින්දා අපිට මෙතන මයිනස් වැලියු වල ඉඳන් කැල්කියුලේට් කරන්න පුළුවන් හැබැයි පොඩි ප්‍රශ්නයක් එනවා ඒක තමයි මේ බිඳුවේදී මේ CK වැලියු එක වෙන වැලියු එකක් තමයි දෙන්නේ වැරදි වැලියු එකක් හරි දැක්කනේ මේ C නෝට් වලට එන්න ඕන හරි නම් ඒ කියන්නේ අපිට DC කොම්පොනන්ට් DC කොෆිෂියන්ට්ස් එක DC කොම්පොනන්ට් එක එන්න ඕන ඒ බෙදීම දෙක මේක තමයි එන්න ඕන හරි හැබැයි අපි K කියන එක බිඳුව දැම්මත් එහෙම බිඳුව දාලා කැල්කියුලේට් කරන්න ගියොත් එහෙම මෙතන බිඳුව තියනවා මෙතනත් බිඳුව තියෙනවා. එතකොට එන්නේ බිඳුව බෙදීම බිඳුව. ඒක ඩිෆයින් කරන්න බෑ. හරි? මෙතන දැන් මෙතන බිඳුව දාපුවම මේක 1 වෙනවා. එතකොට 1 - 1 කියන්නේ බිඳුව. හරි? මෙතනත් බිඳුව වෙනවා. ඒ කියන්නේ ඔතන එන්නේ බිඳුව බෙදීම බිඳුව. හරි? එතකොට අපිට ඕකේ මේ බිඳුව බෙදීම බිඳුව කියන එක අපිට හොයන්න බෑ වැලියු එක. බිඳුව බෙදීම බිඳුවයි නෙවෙයි. හරි? අපිට ඒ වැලියු එක කියන්න බෑ කීයද කියලා. ඒ කියන්නේ ඉතා කුඩා සංඛ්‍යාවක් ඉතා කුඩා සංඛ්‍යාවකින් බෙදනවා. එතකොට ඕක ඉතා කුඩා වෙන්නත් පුළුවන් ඉතා විශාල වෙන්නත් පුළුවන්. හරි? එහෙම නැත්නම් මොකක් හරි වැලියු ෆයිනයිට් වැලියු එකක් වෙන්නත් පුළුවන්. එතකොට මේ බිඳුව බෙදීම බිඳුව කියන එක අපිට ඩිෆයින් කරලා නැහැ මැත්ස් වල. හරි? ඒක කට්ටිය දන්නවා ඇති. බිඳුව බෙදීම බිඳුව කියන එකට වැලියු එකක් හොයන්න බෑ. එතකොට අපි මෙතන k වලට බිඳුව දාලා හොයන්න ගියොත් එහෙම අපිට හරියට වැලියු එකක් එන්නේ නැහැ. ඒකෙන් තමයි මේ c බිඳුව කියන එක වෙනම හොයලා තියෙන්නේ. හරි? මේ C බිඳුව කියන එක වෙනම හොයලා තියෙන්නේ. නැත්තම් මෙයාම පාවිච්චි කරලා අපිට බිඳුවක් හොයන්න පුළුවන්. දැන් මේ C1 හෙව්වා, C2 හෙව්වා, C3 හෙව්වා, C4 හෙව්වා. ඊට පස්සේ C-3 හෙව්වා, C-2 හෙව්වා, C-1 හෙව්වා ඔක්කොම හෙව්වා. හැබැයි බිඳුව දාපුවාම වැඩේ අප්සෙට් යනවා. මොකද්ද වෙන්නේ? බිඳුව බෙදීම බිඳුවක් වෙනවා. So it is not defined. Okay? So that is why we need to use another additional one to calculate this what is called DC component. Okay, so in MATLAB also if you get -1 to 2, that means 0 will come here. Okay, so you have the value 0 divided by 0. Okay, so 0 divided by 0, maybe any value can be given, maybe using MATLAB. Okay, actually that you can see that we can't calculate that. 0 divided by 0, you can't calculate. It is not available. Okay. The MATLAB also can't give a proper value for that. Okay. So one of this value will not calculate that. So it will be a problem. Okay. So to get rid of that things, we are starting here 1. So we just we just avoid the zero value. So 1 to 2 you can get, okay? Now you calculate the CK value, okay? Now CK values are there, okay? So you can calculate the CK value, okay? CK value calculate karna. Then what you have to do? You need to multiply that CK value with the e to the power jk omega naught t, okay? You need to multiply with e to the power jk omega naught t with this value. Then what you have to do? You need to multiply this CK value with this term, okay? So I have coded it here, okay? I have coded it here. So I have done, I get x CK, okay? This calculated CK value is multiplied by the exponential terms, okay? Okay? And this x, okay? So I can calculate this x as the zeroth value, okay? So if I add the zeroth value, the DC component, okay, that is a divided by 2, a divided by 2. So this will be my DC component, and I add it here, okay. So now this for loop is running. What happened? So x is equal to a divided by 2. That is my zeroth harmonic, okay, DC component. This is my DC component. This is the DC component. හරි මේක තමයි DC component එක. හරි. Now k is equal to 1. Now C1 calculated. C1 calculated. C1 is multiplied by e to the power j1 omega naught t, and it should be the zeroth component will be added. Okay. So now I am starting from here actually. Okay. Okay. I am starting it just like it. මේක තේරුම් ගන්න බලන්න. හරි. මේක තේරුම් ගන්න බලන්න. Okay. Now I have the xt, okay? So that C naught value is there, C naught. I have at C naught. That is actually x, a divided by 2, okay? That is x, okay? Then I add the C1, e to the power j1 omega naught, okay? So මේකට තේරුම් ගන්න අමාරුයි දන්නව කට්ටියට. හරි? ඒනකොට පොඩ්ඩක් බලන්න මේක තේරුම් ගන්න. හරි? උට්ටක් අමාරු වෙයි මේක දැන් එකපාරටම තේරෙන්නේ නැති වෙයි සමහර විට. හරි? දැන් බලන්න මෙතන දැන් මේක තමයි DC component. හරි? දැන් මෙතන K පටන් ගන්න 1 වලින්. එතකොට මේ C1 මේවා කරනවා. ඊට පස්සේ එයා calculate කරනවා. ඊට පස්සේ එයා C1 එක මේ C1 එක වැඩි කරනවා මේ exponential terms එකෙන්. මෙන්න මේ term එකේ. K is 1 නේ. හරි? එතකොට e to the power j1 omega naught t. This one is multiplied by this term. Okay? And it added x. X means this one, a to the power 2. Okay? So now it is added here, a divided by 2. That is the DC component. So if this is going one time, so you will have this term. Okay? Now again it is coming to here, and again now k is 1. Again next time k will be 2. Now it is calculating C2. Now using this, it calculating the C2. හරි මේක පාවිච්චි කරලා C2 calculate කරගන්න. C2 මෙහෙම calculate කරගන්න. හරි ඊට පස්සේ දැන් මේ x කියන එක මම define කරලා තියෙන්නේ මෙයා plus මෙයා. Okay? දැන් එතකොට x කියන්නේ මෙයා. දැන් දෙවනි වටේදී what is x? X is up to this level from here to here. දැන් x කියන්නේ මෙයා. මෙතන ඉඳන් මෙතෙන්ට එනකල් x. හරි. ඊට පස්සේ එයාට තමයි add කරන්නේ මෙන්න මේ C2 e to the power j2 omega naught t කියන එක. ඒ කියන්නේ 2 term එක. C2 e to the power j omega naught t 2 කියනවා. හරි. එතකොට ඊට පස්සේ මෙයා තමයි x. හරි. දැන් මෙයානේ x. හරි. ඊට පස්සේ මෙතන 3 නම් ආපහු මෙයා C3 calculate කරගන්න. එතකොට C3 calculate කරගන්නවා. ඒ value එක exponential terms එකෙන් එක වැඩි කරගන්නවා. ඒකට කලින් x මේවා කරගන්නවා. කලින් x කියන්නේ මෙයා. මෙතන ඉඳන් මෙතෙන්ට. එහෙනම් ඊළඟට මෙතෙන්ට ඇඩ් කරගන්නවා C3 එක. එතකොට මොකද වෙන්නේ? මේක මම 10 කරගත්තොත් මෙයා C10ට යනකල් ඇඩ් කරගන්නවා. 15 කරගත්තොත් C15ට යනකල් ඇඩ් කරගන්නවා. එහෙම මෙයා ඇඩ් කර කර යනවානේ. හරි. රයිට්. ඉතින් ඔය ඇඩ් කරපු එක ඕකේ. මේක තේරුණාද කියපේ කතාව? කතාව තේරුම් නැත්නම් පස්සේ මගෙන් ඇවිල්ලා අහන්න මේ ලැබ් එකට හරි ඇවිල්ලා. හරි. එතකොට මම තව ටිකක් මේක එක්ස්ප්ලেইন කරලා දෙන්නම්. ඔකට මේ කෝඩ් ටික පුළුවන් නම් මේ ওই ස්ක්‍රීන්ෂොට් එකක් හරි ගහගෙන MATLAB වල කෝඩ් කරලා බලන්න. හරි. මොකද වෙන්නේ කියලා. එතකොට ඔකටට තේරෙන්නේ නැහැ. ඔකට තනියම කරන්න ඕනේ. එතකොට තමයි තේරෙන්නේ. හරි. නිකන් මම ගිරව වගේ කිව්වට මේ ටික තේරෙන්නේ නැහැ ඔකටට. ඕකේ. You need to do this. Then you can understand the things. Okay. So here what I am doing, I am just evaluating this summation actually. මම අර for loops එක පාවිච්චි කරලා කරන්නේ මෙන්න මේ summation එක evaluate කරනවා. හරි. මේ summation එක evaluate කරනවා. දැන් ඇත්තටම මම මෙතන මේ plus පැත්තට විතර එකතු කරලා තියෙන්නේ. හැබැයි ප්‍රශ්නයක් නෑ. හරි plus පැත්තට එකතු කරලා ප්‍රශ්නයක් නෑ. මොකද දැන් අපිට කොහොමද අනන්තයක් එකතු කරන්න බෑනේ මේ වැලියු. යම් කිසි limited ගානක් තමයි එකතු කරන්න පුළුවන්. දැන් මේ minus පැත්තත් ඔය කට්ටියට එකතු කරන්න පුළුවන් ප්‍රශ්නයක් නෑ. හරි. හැබැයි ඒකට වෙනම ලියන්න වෙනවා මේක. හරි. If you want to add minus, so same one you can use, but you need to define it from minus value. Okay. So for example, you can do the same thing. Okay. So let's say that you are evaluating this 1 to 2, then here you can use it to -1 to -2. So I think same things you can get. Okay. Same thing you can get. Let's see. Yeah. So that means here we are evaluating plus value. After that, we are adding minus value. Okay. So plus and minus value added. Okay. Using this. Okay. So now, if you plot this, okay. Now this is the signal. This is the signal. Okay. X is actually this one. Okay. So minus value and zeroth value and plus value added. So this is the X. And if we plot this X, we should have that rectangular pulse, this rectangle pulse train we should have. Okay, if we plot this. Okay, so this is the sum. Okay, so I am adding the component, I am adding the exponential terms. Okay, so if I plot this, okay, for example, if I run this, now it will plot. Okay, so you can see that this kind of sinusoidal signal only we can get. Okay. So if you add in more values, let's see that more values what happen. Okay, so you can see that. So if you add 1 or 2 values, let's see what happen. You will get this one. Okay. Okay. Actually, it cannot be a sinusoidal signal because 2 frequency components are there. Because it will have C1 and also it will have C2. Okay, so 2 frequency components should be there. Okay. So it should be a sinus, it cannot be a sinusoid. Let's remove this one. So maybe this is not a sinusoidal value. It is just, we can see it as a sinusoidal value, but maybe it is not a sinusoidal value. Okay. Uh, so anyway, so that is we add in two components. Okay. So if we add in three components, okay, three components, let's see what is the work, what is the things we can. Okay. Now you can see that this kind of one you get. Okay. This kind of one you get. Okay. Now you can see that it is somewhat equal to a, so you can see that the shape is there. Okay. The shape is there now. Okay. The shape is there. Okay. So, but there is a ripple, no? So if we add more values, let's say that 6 or 7, 8. So now you can see that actually there's a problem with this one because so as you see, oh yeah, it is correct, no? Okay. But this value should be 1 or 2. This, because this amplitude is 2, no? We select it as 2. So this should be 2, not 1.6. Okay, anyway, you can see now. Now it is somewhat like this, okay? So we have, so this is somewhat equal, okay? But if we add more component, let's say that 800 components or something, so now you can see that it is very much equal to the corresponding value, no? Corresponding time value. But the problem is that the amplitude is not better. I think there is, so maybe some mistake I have done when I'm coding this equations, okay? So maybe because this amplitude should be 2 actually. Amplitude should be 2. Okay, but you can see that the shape is coming, no? When you add in more signal, more component, that means this signal is look like same as a rectangle, but still there are some problems, okay? If we have 800 terms, so still it is not same, but there are some, so this is not smooth, okay? So it is not, it is actually 100% not equal to this signal, okay? Because here some ripples are there. But if you add in more and more components, so this will be same, okay? So actually that is the concept of Fourier series representation, okay? By adding this type of complex exponential terms, you can generate any kind of signal, okay? So we see this one, okay? Practically, we see this number, okay? So we find the Fourier series coefficients and Fourier series representation. And if we add in more and more components, this kind of signal we can get, okay? So that is the things you should understand here, okay? So I hope you get it, okay? So that is the basic idea of the Fourier series representation. හරි? ඒක තමයි Fourier series representation එකේ idea එක. හරි? මේක තේරුණාද කට්ටියට? Okay, please get a screenshot of this code and try to run this. And if there, so please check whether there is any problem. Okay, is there any problem related with this one? Okay. Actually, this exponential terms you can use as a, you can also write as a sinusoidal terms, okay? So here I have written sinusoidal terms, okay? As a sinusoidal terms, okay? So you can run, you can also write this one, and you can run this code also. So if you add sinusoidal signal together and together, again we can get the rectangular paths, okay? So that is the things that is actually happening in Fourier series, okay? ඕනම සිග්නල් එකක් හාමොනික් වල එකතුවක් විදිහට ලියන්න පුළුවන්. ඒ හාමොනික් ටික එකතු කරපුවාම මේ වේටේජ් එකෙන් අපිට ආපහු ඒ සිග්නල් එක එන්න ඕනේ. ඒක තමයි මම මේකෙන් පෙන්වන්නේ, okay? We can represent any signal as a collection of ඒක තේරුණාද මම දැන් කරපු වැඩේ ඔය කට්ටියට? හරිද? මම කරේ මේක. හරි. මම කරේ මේ සිග්නල් එක periodic signal එක. This is a periodic signal. I have found the harmonics value, okay, using this identity, okay? So this weightage can be calculated using this integration. Now I have calculated that weightage also. So I can calculate the weightage here. So I can represent this signal as a collection of, as a sum of these complex exponential terms with respect to, by multiplying with the corresponding coefficients, Fourier series coefficients or this weightage, okay? So I have found the weightage and I have found this series, okay? Okay. So I can write it, okay? So මම මේක ලියාගත්තා මෙන්න මේ විදිහට ලියාගත්තා. හරි? අර value පාවිච්චි කරලා අපේ signal එක මේ විදිහට මම ලියාගත්තා. Complex exponential terms වල එකතුවක් විදිහට. Then using MATLAB වලින් කරේ අර complex exponential terms ටික එකතු කරලා ආපහු මම බලනවා ආපහු අර signal එක එනවද කියලා. හරි? එතකොට මට පේනවා මේ මෙන්න මේ sample මෙන්න මේ harmonic ගාන වැඩි කරන්න මට එන signal එක මෙයාගේ shape එකට එන්න ලං වෙනවා කියලා. හරි? Actually that is the idea of the Fourier series. හරි? ඒක තමයි Fourier series එකේ idea. Right? දැන් ඔකට ටික තේරුණාද මම කියපු එක? කරපු දෙය. දැන් අපි තාම discrete time එකට ගියේ නැහැ. දැන් ලබන සතියේ discrete time එකට යමු. හරි? හෙට ක්ලාස් එකේදී ගානක් දෙයක් හදලා discrete time එකට යමු. මේක තේරුණාද? මේක තේරුම් නැත්නම් ආපහු අහන්න මට කියලා දෙන්න පුළුවන් ආපහු. මම ඒ වුණාට හිතනවා ඔය කට්ටිය මේක තනියම තේරුම් ගන්න බැලුවා නම් හොඳයි කියලා. හරි? තේරුම් ගන්න බලලා තේරෙන්නේ නැත්නම් මගෙන් ඇවිල්ලා අහන්න මේක මොකක්ද කියලා. හරි? Then I can explain it to you very well. Okay? මම හිතනවා ඒක තමයි හොඳම වැඩේ කියලා. So are there any problems? මොනවද ප්‍රශ්න තියෙනවද? So if you doesn't have any problem, you can just mark your attendance and you can leave, okay? But if you have any problem, you can ask me now, okay? If there is no any problem, now you can leave actually after